Hi, everybody. Welcome to the second edition of the FRC workshop series for Australian teams. Tonight, we're really happy to welcome Project Bucephalus, FRC team 5985, to do a presentation on some basic tool training. These guys are definitely one of the premier teams here in Australia, and this year they won one of the Chairman's Awards. I believe it was at the Southern Cross Regional, so congratulations on that. And they have two of their, I guess, early mentors on this, so newish mentors. We have Isaac and Lewin. So welcome. I'm going to turn it over to you guys. Have a great time, and I know everyone's going to really enjoy it.
Awesome. Thank you.
Okay, so hi, we're doing a presentation we've decided to call Fingers and How to Keep Them. We should have slides up in a moment. Right, there we go.
Yep.
So we're just going to cover some basic tool use and safety, as well as what the bare minimum rookie toolkit should be. So what tools you should go out and get if this is your first time doing FRC, or if you just want to improve the quality of your workshop if you've been working out of a garage or similar.
So I can't see the mouse. Where is the mouse? Okay, found it. Wait, what? Where's the? Okay. Okay, so what we'll cover, as Isaac said, the bare minimum rookies toolkit. So what tools you pretty much need to be able to do FRC to a decent level. Then we've got just a few little funny safety video things just to liven up the mood, I guess. Then we'll run through a what's wrong with this picture, like safety quiz. So we've got people using tools, and then we'll run through what's wrong in those pictures. And then we'll go over some of the tools and how to properly use them and how to clean them and stuff. So let's get right into it.
Yeah. So the first category of tools that most teams will need is what we've decided to call twisty things. These are Allen keys, spanners, screwdrivers. You're going to want to make sure you have both metric and imperial for the screwdrivers and spanners. So it's the Allen keys and spanners, and Phillips head and flathead screwdrivers, particularly if you're working with parts from multiple companies or multiple different retailers, because even though they might be very similar in size, a metric part doesn't always work with an imperial part and vice versa.
Yeah, so you've got different types of screwdrivers as well. You have some really long ones and some really short ones. The short stubby ones are generally for tighter places. The ones with that are short and stubby and have the thick handles allow you to get more torque when you need them in a smaller area, as opposed to the other small ones that have smaller handles. They give you less torque. The spanners, you've got your open end that you can use to get in if you only have one access point and you can't go over it. And then the other end of it, you can slide up over a nut or over the top of a bolt head to secure it whilst you turn it on the other side.
The second category is linear motion material removing things. So hacksaws, sandpaper, files, all various bits and pieces required to remove material.
I've got the sandpaper, but yeah,
yep.
These are what we've got.
Yeah, so hacksaws, as well as having the hacksaw itself, you're going to want to have different hacksaw blades for cutting through different materials. Depending on what thickness of metal you're using or what type of wood you're using, your blade requirements will be different. And the same also applies to the sandpaper and the files. You're going to want to have a few different types depending on what materials you're actually using. We'll go over the best ways to use these later in the presentation.
And with the hacksaw blades, we'll cover what the best thickness of material and the best type of blade is to use for each material. Our naming scheme, we tried to group them together as much as possible. So we have rotary motion material removing things, so we've got the main part, I guess, is the drill. And then you've got the bits that can go onto the drill, your standard drill bits and your hole saws.
Yeah, so once again, it's always a very good idea to have a set of imperial and metric drill bits, because sometimes you just really need a hole to be a specific size, usually for a prefabricated part like a gearbox, and a close approximation won't quite cut it.
For example, with a hole saw in Australia, you can get, I think it's an 18mm hole saw that is quite close to the 1 1/8 inch bearing hole that you need. But when you then go to put a bearing into that hole, it wobbles around like crazy. And so you get a lot of inefficiency in your gearbox. So it's really good to have at least that one specific hole saw for bearings that is exactly 1 1/8 inch in diameter.
Also, having a good hand drill that doesn't need a power cord running to it. You want to make sure you have one that has both adjustable torque and adjustable speed. We'll cover how to use those later in the presentation. The next category is cleaning things. So you are going to want to have a bunch of different things for cleaning up after yourself. Usually there's like a broom, dustpan, and brush, a garbage bin that you can put wood and metal scraps into without worrying about tearing through garbage bags or getting it mixed up with the wrong type of waste. In particular, it says about a shop broom. You want one that's nice and wide with thick bristles so that you can actually deal with the heavier particles created by cutting through metal.
You've got your dustpan and brush as well. That's useful for your bench tops and cleaning around if you have like a set desk piece. So such as a vise, you're not really able to get a broom up under here. And so you want a nice, useful dustpan and brush that's not broken to get in there and get into all the nooks and crannies underneath this vise to collect all the stuff that you've drilled out or cut out of your material.
Yeah. Shop vacs are also very good for cleaning up spaces where you can't get brushes in, particularly anywhere where, like again, around vices where you've got lots of small holes that particles can end up in that can cause a lot of potential issues if they're left there without being cleaned. We also recommend having multiple parts trays to put loose pieces in so you don't lose track of them or accidentally dispose of them with the rest of your actual waste.
That's everything from this slide, yeah?
Yep. Now, in regards to safety, you're going to want to have sets of cut-proof gloves. These are useful both for carrying robots as well as for holding on to sharp pieces of metal while you're working with them, or using a file or anything that you're at risk of cutting yourself or losing a bit of skin by mistake. Safety glasses are incredibly important. They protect your eyes from loose particles in the air, and as well as just like stuff flying everywhere as you're cutting through material. Earmuffs are also required for anything that generates a potentially damaging noise level, which happens quite frequently with power tools. It's also a good idea to have some form of robot barricade. So not just like plastic cones or anything sitting around to say the robot isn't allowed to leave this area. You're going to want to have something solid that will physically stop a robot from leaving the area it's supposed to be in, while also signifying to people that they shouldn't enter this zone because there may be an active robot.
So you might have cones or tape or something like that and go, yeah, our drivers are fine. They're not going to go through it. Accidents do happen, especially in programming autonomous. You may have forgotten to plug in an encoder or something. And so your robot can just go haywire and run straight out into your workshop and knock people over and potentially injure them pretty severely.
Yeah, we are definitely speaking from experience in this regard. A few years ago, we had a team member who had a robot almost eat their leg because they were standing in the wrong spot at the wrong time. So robot-proof barriers are definitely a must.
Another must is a protective sheet. So we use the protective sheet mainly on our robot when we're doing stuff in the pit, or if our robot's near completion and we're just adding some finishing touches. We use it to cover our electronics and that prevents any particles of metal or wood or polycarb getting into them and screwing up the internals and short-circuiting them. So whenever we're cutting or drilling out rivets on the robot, we will bring over our protective sheet and put it over the electronics to stop anything going in there.
Yeah, so a few other things, you've got the electrical components. So you want to have a multimeter so that you can, among other things, check to see if your electrical system is contacting your robot's frame anywhere and causing a potential short circuit or shock risk. This is something that the robot inspectors will also check for during the inspection at the competition. Crimpers, a crimper is a very important piece of electrical toolkit. You use it to attach the correct ends to various lengths of cables. Insulated screwdrivers are very important for disconnecting and reconnecting electrical cables that need screws to connect to them, as well as working with any electrical connections that it would be otherwise difficult to reach into with your hands.
Yeah, you shouldn't be working on your robot whilst the battery's in there and connected and live, but sometimes in the pit things can get heated and you might accidentally do that. So having an insulated screwdriver set is good for the pit, especially just in case you accidentally contact something that is live.
Yeah, in general with safety procedures, you want to avoid hazardous scenarios wherever possible, but also keep yourself covered in case something does happen without you realizing it.
Another important part for your electrical toolkit is your soldering iron. So it can be used for any connections or custom PCBs that you want to connect wires to, or sometimes you might just want to solder two wires together. I know teams solder their battery connectors together in their for their robot batteries. So a soldering iron can be used to heat up a metal that has a low melting point, and you can melt it in amongst your wires. It'll then solidify and join those wires together and have a strong electrical connection between them.
So for measurement and precision, like marking out where things go, having tape measure and metal ruler are both, again, very important things to have. You want to make sure that you have both metric and imperial measurements because, as I've said earlier, there are all sorts of prefabricated parts that use different measuring systems, as well as the field itself is measured using imperial. And if you're in a country that does use metric most of the time, you will need to convert between them at one point or another.
Quite often, quite often. Yeah. Another important part for marking stuff out is a center punch and a scribe. So a scribe can be used on mainly metal. It can also be used on plastic. It puts a physical mark in the material, giving you a visual spot for you to go to each time. Whereas with a marker, you might accidentally rub over it and rub it out or smudge it.
Yeah, the scribe is basically like a pencil for when you're working with metal. Also important is a center punch paired with a hammer or a mallet. You want to use that to create a small indentation where you're planning on drilling a hole to make sure that the drill bit doesn't wander as you're trying to drill into it.
Is that it for the...
Yeah, and then these are the other things that you will need that didn't fit into any particular category. But number one, most important thing that you will need is a workbench with a vise of some description so that you can clamp the parts you're working on and actually work with them safely. Under no circumstances should you be attempting to work on parts that you're holding in place with your bare hands, because you cannot hold something as tight as a vise or other type of clamp can.
Another really important part for a rookie toolkit would be a rivet gun. So on the left there, you've got the small rivet gun. That is, It's a very difficult piece that you need a lot of strength to be able to pop a rivet using it, because you need to grip it pretty much like that and just squeeze. The large rivet gun, on the other hand, it's so much easier. You can use a hand on each handle and just squeeze it together, and you don't have to worry about your fingers getting caught in between. It allows you to pop rivets with a lot less effort, and it takes a lot less time to do so.
Yeah. But better than both of those is, of course, an electrical or pneumatic rivet gun, but those can get expensive, particularly for a beginning team. Yeah. Pliers are also something that's quite needed. They can be used for holding things in place, for bending metal, for helping to take apart or put together nuts and bolts. And most pliers also have a cutting portion of them that can be used to cut cable ties or electrical wires.
Another important thing you'd need is quick grip clamps. So they can be used in place of a vise, where if you have something really long and say you can't just clamp it in the small portion of the vise, you can clamp it along the whole desk by using a quick grip clamp at each end. It'll secure it in place and it won't move. They're really easy to use, and they can hold a piece really strongly to your bench. Your bench does have to be solid though in that case.
Yeah, you also want to look at having some form of storage for your equipment. So in your rookie year, you will get 2 totes with your kit of parts, and every year after that, you'll get another one. These totes, they're quite large. They're very good for storing large quantities of materials, but they're not that great for storing things like small fasteners like nuts, bolts, rivets, etc. Often we use things like the boxes that electronics components come in for storing things like that, as you can see in the pictures.
So the Vex boxes, they come with planetary gearboxes most of the time, and other boxes that you get from AndyMark or Vex are really handy to store these smaller components because they're fully enclosed, there aren't any big gaps, and they stack nicely. So you can stack them on a shelf in either direction, either lengthways or vertically, and they're just really nice to use.
Then,
Yeah,
but then also got a few things that are nice to have but not essential.
Yeah.
So among these, we've got a jigsaw. This is basically a mechanical electrical version of a regular hacksaw that can be used in a variety of different ways. In particular, it's very good for cutting around corners in curves, or cutting unique shapes out of pieces of material that it would sometimes be quite difficult to get a hacksaw in place to do so.
Another thing that would be nice to have for a rookie team is a step bit. So a step bit has multiple sections on it of different sizes. So where you would need to store a full set of hole saws, you can buy one step bit and it will have multiple stages on it. They're really good for widening holes, or in this case, I believe our one has the 1 1/8 inch bearing size hole at the top. And so we can just plunge the step bit straight through our material, and the hole at the end is the perfect size for a bearing.
Yeah. Next thing on there, the socket set. Although they aren't a necessity for tightening nuts and bolts together, they do make it a lot easier on your hands because they have a ratcheting feature which allows you to just move back and forth instead of having to turn one end constantly.
As Isaac mentioned earlier, the electric rivet gun is on there. It makes it so much easier to do any type of rivet. It's literally just a press of a button. You don't need to put any real effort into it, and it takes a fraction of the time as well.
Yep. Then Anderson and battery lug crimpers, they're good for if you're wanting to get into more advanced electrical wiring, but aren't strictly necessary if you buy the necessary pre-made electrical components.
Another thing on there that is unlabeled is the quick set square. So it has a thick edge that you can rest against something, and then you can just rule a straight line that you know is 90 degrees across it.
Also, for things that would be nice to have is storage. So some forms of compartmentalized storage is a lot better for storing those small components than using the small cardboard boxes from Vex that we were talking about earlier, because that way you can fit multiple components into the same box, and with most of them you can rearrange the compartments to have them stored however you like.
The tactics boxes are really good for that. You can pull out those orange partitions and you can adjust them to make the compartments bigger or smaller depending on what you're storing in there.
Some form of mobile tool chest is also a very good idea. So you have a central location where all of your hand tools are stored. We use the Ryobi tool blocks, which are pictured there. It comes apart into different sections, and we can just pack all those into the car, sit our robot on top, and that's 90% of our pit for the competition packed up and ready to go.
Another thing that we use a lot is EV3 or NXT boxes for the education kit boxes. They have compartments already built into them, but you can remove them if you want to. So we use them a lot as parts trays, and then we store larger components in the box itself.
Yeah, those are especially good for teams that started out with first LEGO League or run LEGO Mindstorm's robotics classes, because they will tend to have a bunch of those lying around that they can then use for storage. Right, so are there any questions about anything we've gone through so far?
Can we see the live stream at all? No. Okay. Is that a no? Or what do we wait for? Okay. We'll be right back. No? Keep going? Okay.
Okay. So we're just going to show a few safety-related videos.
Oh, I'll get back. Hold on.
You mean you'll work on engines and machinery and not think of your own personal safety? Here, shake hands with danger.
Shake hands with danger. Need a guy who ought to know. I used to laugh at safety. Now they call me Three-Finger Joe. Shake hands with danger. Find it anywhere you choose. Be careless for a moment. Spend a lifetime with the blues. Shake hands with danger. 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 And friends I used to know, compared to them I'm lucky to be just Three-Finger Joe.
Wait, no, I can't. It's an ad from the 70s by Caterpillar, the guys that make those big excavators.
Hello there. My name is Dr. Albert, and I specialize in workplace safety. Now, everywhere I go, people tend to agree that safety is no laughing matter. But what if I told you that there was a way to give your employees proper safety training while keeping them entertained and interested at the same time? Sound too good to be true? Well, that's where the new Wrong Way, Right Way safety cases from DuPont Sustainable Solutions comes into play. Cool, huh? You see, in the science of safety, we believe there are two basic ways to perform a task: the wrong way and the right way. When you perform a task the wrong way, it is dangerous, unprofessional, and can be life-threatening. But if if you perform a task the right way in the workplace. It is efficient, safe, and meets with industry standards.
That's a video from DuPont Safety Specialist, I think it was. And now this is probably something you've all seen going around. It's from a... Huh? Next slide? Okay. This is now not doing anything. Okay, there we go.
Yeah, so we're just going to show a bunch of different pictures. It's going to ask you to put in the comment chat or the video chat what you think is wrong with the picture. So start off with this one. It's been around the internet a few times. There is one major thing wrong with this picture.
We'll give like 15 seconds per thing, and then we'll just talk through it ourselves.
Yep. So as some of you may have noticed, the girl here, she is actually holding the soldering iron by the metal part of it, which is the bit that heats up when you actually use it. On to the next picture. There's a couple of things wrong with this picture. One of them is very obvious. The second one is slightly less obvious. So starting off with the more obvious one, the man is holding a pedestal drill sideways, trying to use it instead of leaving it bolted down on a workbench. The less obvious thing that's wrong with this is that the piece of material is not actually clamped correctly. As it is being held in place by the thin end instead of the thicker end, this will result in it tipping over fairly easily and coming loose from the clamp. It's also clamped onto a chair, which can be quite easily knocked over, particularly as the man is holding a fairly heavy pedestal drill. Moving on to this next one.
That's at least a two-person lift.
Oh, the pedestal
yeah.
drill, yeah.
Yeah.
Our mentor who's watching the live stream has just said that that pedestal drill would be a two-person lift, which, yes, it would be.
Yeah, yet another thing wrong with that picture. Moving on to the next one here. We have a man using an angle grinder on a piece of metal. Again, there's something very obviously wrong with that and something slightly less obviously wrong. The very obvious one is that his hand is way too close to the blade. And in fact, his arms are crossing over underneath the blade, which is very dangerous. And secondly, he isn't wearing any personal protective equipment. No safety glasses, no earmuffs, and his arms are completely uncovered, leaving them exposed to the sparks being generated by the angle grinder.
So with this one, if you're active on Reddit, you've probably come across this before. It's an FTC student. And yeah, there's two pretty obvious things wrong with this picture. I guess three, maybe, yeah. So I'll give you guys a few seconds to just see if you can figure it out yourself. But yeah, so the first one is that he is drilling into his leg. The piece is not clamped onto a bench, and really the main thing holding it down is his hand, and there's also a rubber band around his leg and around the wheel that is holding it in place. So the second thing wrong is that he, again, is not wearing any PPE at all. He's got no, in this case, mainly no eye protection. And then because he's drilling so close to his hands, he should probably be wearing gloves as well. Okay, so in this image, there's three main things wrong with it. I'll give you guys again a few seconds to just kind of look over it and see if you can come up with them yourselves. So the first primary thing is that it's incorrectly clamped. He's clamping it to this guy's back with his foot, and that is all. There's no proper clamp or proper workbench in place. The second main thing wrong with it is that he's cutting towards someone. So in this case, it's not necessarily towards himself, but it is towards this other poor guy that he's got the workpiece clamped to. Then the third, probably least obvious one, is that the second person who is acting as the workbench is not wearing any PPE. So he doesn't have on any earmuffs or eye protection that this guy that's actually doing the cutting does.
Yeah, this is a slightly humorous and possibly dramatized image that is unlikely to ever happen in real life, but you should always be aware that just because the person using a tool is wearing the right safety equipment doesn't mean that the people standing next to them are also wearing the right safety equipment.
So again, here's an image. There's a few things wrong with it. So same as the last one, it's incorrectly clamped. He's just resting this piece of wood on his leg and he's holding it with his hand.
In particular, the piece of wood that he's cutting, once he's finished cutting it, the part on the end is going to be sent flying by the spinning blade of the saw, as there is absolutely nothing holding it in place.
Another thing wrong with it is that he's cutting way too close to his body. This saw looks like it is pretty much brushing up against his leg, which is not great at all. You want to keep yourself as far away from the tool as possible. And lastly, he is not wearing any PPE at all. It looks like he has some sunglasses, which would be better than nothing, really, but they're just hanging on his neck. He hasn't got any earmuffs on or any safety protective eyewear or gloves. Oh, is this the last one?
No.
Yeah. So this one is one that we took yesterday. There are at least 7 things wrong with this picture. Some of them might not be as obvious as others.
So we'll just let you try and come up with a few of those now.
So one of the first thing is that his arm is underneath the angle grinder, which again, the same as that picture before, is you don't want your hand anywhere near something that is spinning at thousands of RPM, especially when you're cutting something. Another thing wrong is that he's cutting above exposed electronics. So the sheet we were talking about earlier, the protective sheet, he should have that on the electronics. In the first place, he shouldn't be angle grinding over the electronics. But if you were to do any work, you would have a protective sheet over the electronics to stop material from getting in there. The workpiece is incorrectly clamped. So the piece of polycarb that he is cutting is clamped between a battery, a robot battery, and his hand. So if the angle grinder actually grabbed onto that, it's going to send it flying. There's nothing proper happening there. Yeah, as discussed in the last one, it is resting on top of a robot battery. If anything were to pierce that battery, it would be spilling lead acid, which is certainly not good for you at all. You would need to get your battery spill kit immediately. Pretty common one across all of these images. He has no PPE on, no safety glasses, no earmuffs. He has long sleeves, but they're pushed up, and he has no gloves on at all. Yeah, so loose clothing as well near the tools. He has his hoodie strings that are just hanging. When you're doing work and you're wearing a hoodie, so we've got ours tucked in, you want to tuck them into your shirt, or you can tie them up here somehow.
Or you can just take your jacket off, find something else to cover your arms with.
And lastly, he's using an angle grinder to cut polycarb, which is not ideal.
And
yeah, that's just for the safety of the image.
Yeah, and it will, in fact, if you were to try to use an angle grinder to cut polycarb in a situation like this one, would result in melting through the polycarb and potentially damaging the angle grinder.
Yeah. So an angle grinder will spin too quickly, and there's not much speed control on an angle grinder, or on ours at least. And so it'll just melt the polycarb around where it's cutting and fling molten plastic all around the place, which you definitely do not want.
Yeah, so any questions about any of the stuff we just went through?
Oh, the line's popped up.
Yeah, so there was a question that came in. Do you guys have any tips for pit safety?
Yeah. Yeah. So for pit safety, number one rule is you never want to have more than about 5 people in your pit area at a time. Because if you have too many people in there, it can get very crowded, and it's very easy to accidentally bump into someone while they're using a tool, or to just have people get in the way.
Another thing, especially in this time, I guess, is it's a 3 by 3 meter space. And so you've got 9 square meters of space, which at this stage, you're only able to fit 2 people into due to the COVID restrictions. So that's something that if they're still around, we'll have to look out for. We also have a first aid kit in a really accessible place, as well as a battery spill kit, which is rubber gloves and bicarb soda pretty much. As well as we have a safety checklist whenever we want to bring the robot in or push the robot out. We check over the robot and see if there are any tools left in it or things that need to be done up so that our robot doesn't break on the field or kill someone in transit.
Yeah. So something you should also always be mindful of is what kind of material the floor of your pit area is made out of. And if there are any restrictions on tool use put in place by the venue that you're currently in, you may need to go to a designated machine shop area to do work on components of your robot. And 90% of the time, you really should be using a shop vac or a protective cloth or a combination of the two to make sure you don't end up with metal shavings or polycarb dust or anything like that scattered all around your pit area and your neighbor's pits.
Alrighty. Was that the only question?
So far, that's the only question. I'll pop back in if there are more.
Awesome. Thank you.
So now we're just going to go through some of the basic procedures required, where procedures and safety with using some basic tools. Do them first. So you're going to start off with measuring when cutting material. So when you're measuring out your material to cut it, first of all, you need to make sure that you keep your tape measure or ruler straight and flat at all times. If it's sitting at an angle, you're not going to measure the exact distance you're aiming for. If you don't have a set square, you can get a 90-degree angle by measuring and marking 2 points on the piece of material, then putting a ruler or other straight edge between the 2 points to mark a line between them.
So when you want to measure something longer than your ruler, so in our case, longer than 300 millimeters or 30 centimeters, you'll want to mark one spot at 30 centimeters and then bring the ruler to that mark again and mark wherever you want to mark it. You can repeat this process multiple times if you need to. So we're going to walk through how to do some pretty basic measuring. We've got 2 bits of 1 by 1 inch aluminium tubing that we are going to cut to the same length and then bolt together. We're then going to mark and cut this polycarb and put it on top with rivets. We'll just do the measuring for now, and then we'll do each step as we walk through the tool required. How do we do this?
20 centimeters.
20 centimeters, all right.
Yep. So to start with, you want to get your ruler or tape measure, make sure it is completely level, and make a small mark against the marking on the ruler where you're wanting to go to. Then want to move it to the other side and do the same thing. So you should then have 2 marks like this.
Hold on, just wait, we're getting zoomed in, I believe. Is this better?
I don't know how well you can see it, but you should have, and if I angle it away from the lights. two marks on here. So if you then get your ruler and you line it up against the 2 marks, you can then get a more accurate 90-degree line going across the edge of the material.
So for a silver piece of material like this, one way you can do it is just with the line. If you want to use a scribe for a more accurate measurement, you can color both sides of the line and then get the scribe and scratch along in the middle. That will create, there'll be a whole black area, and then there'll be this silver line straight through the center, which will contrast with the permanent marker, and you'll definitely be able to see it then. So we're going to do the same on this piece of material. We're going to measure, because this bit is black and anodized, a black permanent marker isn't necessarily going to show up on it at all. So for this one, we're going to use the scribe. We want to mark at the 20 centimeter line by scratching the anodizing off of the tubing. We want to mark it on each side. Our scribe is not sharp. We need to get a new one. But then you want to go and line those 2 marks up and scratch right across it.
Yep. And I'll just bring this over to the camera. So, as you now see, we now have this silver line right here to scratch into the metal where the scribe wore away at the undermarking. That's a lot easier to see than if you try to use a permanent marker on the black metal.
So with the polycarb piece here, we'll do the same thing. We'll get our ruler, measure to where we want. In this case, we're going to go to
10 centimeters.
10 centimeters or 100 millimeters. I'm going to mark on one side. I'm going to come over to the other one, mark on the other side, put the ruler between those 2 marks, and then just rule across.
Now, if you're trying to cut a piece of material that is wider than the ruler is long, you can do multiple marks line up. So for instance, if this piece of material was like 50 centimeters wide, you need to do at least 3 separate marks along the length of it.
Yeah, so you'd measure on one edge, on the other edge, and then you'd also measure directly up from the middle.
And then you do 2 lines, one from one edge to the middle, and the other one from the middle to the other side.
Okay, so the next tool we're going to demonstrate is the hacksaw. Yeah, let me jump back to the slideshow real quick. Or actually, I should be able to do it from here.
Do you have the other blades?
No, I just have the one blade. And then I've lost the actual cursor. Yep, there we go. Okay, so here we go. So with a hacksaw, there are 3 main risks with it, or 4 really. You can break the teeth on the hacksaw, which then means it's pretty useless at cutting. When you cut with the hacksaw, the metal you cut can be pretty sharp, so you need to watch out for that. And then also you can have a loose blade. The other main risk is actually cutting yourself whilst you're using a hacksaw. So we recommend you wear gloves whilst doing so. We forgot the gloves. Isaac, can you run it?
Yeah, I'll go grab the gloves.
I can do the hacksaw stuff. I've got it here. So
that's the thin one.
Yeah. So for hacksaws, you have 3 main types of blades. You have an 18 tooth per inch blade. So that means that for every inch of the blade, there are 18 teeth. You have a 24 tooth per inch blade, which again, for every inch on the blade, there's 24 teeth. And then you have a 32 teeth per inch blade. So for every inch, there are 32 teeth. For the 18 tooth per inch one, your main thickness that you're going to be cutting through is of minimum thickness 4 millimeters. For the 24 tooth per inch one, the minimum thickness is 3 millimeters. And for the 32 tooth per inch one, the minimum thickness is 2.5 millimeters. When you're using a hacksaw, you want to keep it nice and straight and hold it on both ends. You want to apply force as you push forward, because you should set up your hacksaw so that the blade has cuts on the push stroke that allows you to put more of the blade in. Most hacksaws have a nuts on the end. Oh, where's the white over this side? There. So it has an, and this bit will come loose. Then you can take the blade out. So the more teeth there are, the more cuts it does when you push it across a material. On a harder material like metal, you're going to want to have more teeth so that you have more little cuts on the material. Seized up here. This hacksaw is so bad.
Yeah, we need to get a new hacksaw at some point. Yeah, that's something you need to be careful of when putting a blade in, because when you tighten it, the blade will be under tension. If it isn't sitting in the spikes properly, it will eject itself and potentially cut someone.
You need to make sure the actual frame itself is sturdy.
Yep. Then when you clamp your piece of material into the vise, you want to make sure that the section that you're cutting is close to the edge of the vise, but not so close that the hacksaw is going to be rubbing against it as you make the cut. You also want to make sure it's clamped in well enough that you can yank on it without it coming out. Then as you cut, you want to hold it so you've got your index finger pointing along the length of the hack, your arm moving in the same back and forth pattern. Then you want to push down and forward and then pull down and back.
When you're cutting, on your downward stroke, when you're pushing, you're going to want to apply pressure pushing, and then when you're pulling, you don't have to apply as much pressure, because you're not going to be cutting anything while pulling the hacksaw back, since the teeth are only facing one certain direction. With a hacksaw, if it starts to drift in a certain direction, you can tilt the hacksaw itself in the opposite direction to where you're drifting, and it will pull itself back on track.
So as you see, I'm currently having to tilt this almost 45 degrees because the blade itself was turning and slicing through the end of the material.
I mean, I guess we should move the microphone over here. So once you finish your cut, you're going to have a piece of metal that has some very sharp edges on it. So you're going to want to use a file. Let's bring up the slide. Yeah, you got that bit. Okay, a file. So with your file, you've got three main risks: applying too much pressure, accidentally filing yourself, and breaking the file. The first of these leads to the third, which can then lead to the second. So there are three main types of files. You have a flat file. You have a half round file, which has a flat end and then a half round end. So it's a semicircle. And then you have a full round file. This is a small version of one. Let's do this trick. So you're going to want to clamp it in the vise, and then it will cut on the push, the same as a hacksaw. And so you'll push and lift and come back, and push and lift and come back. and that will remove any sharp edges from your piece. This is very useful on your robot in corners. So from like on the corner of box tubing, you can just push up on the corner and it will remove it entirely, so you can't cut yourself. Part of inspection is the inspector will run over your robot and find if there are any edges that they can cut themselves on. So to make a file safer, jump back to the so keeping a file clean is very important. You can use a file brush, so a wire brush that you run over the file, and it will go in between each of the teeth of the file and clean out any pieces. Keeping them sharp is done by removing the bits from inside, and then also not using files as a hammer or a pry bar. So files are made out of a really hard metal. That's why they're able to take material off of other metals like aluminium and steel. So with the metal being hard, it is also very brittle. So if you use it as a pry bar, it is going to snap under extremely low loads. I guess we'll just move it to one. Yeah. The next one on our list is the jigsaw. So we have our jigsaw here. It has the battery in it. So this is, oh wait, no, the camera's over here. Wait.
Sorry.
All good. Yeah, we'll need to move it.
Yeah, true. So your jigsaw may vary from ours. Ours is a Ryobi cordless jigsaw. It has 3 locations where like you can change the settings. You have, oh no, I guess I'll go through the wrists first, yeah. So you've got bending your jigsaw blades, breaking the teeth on the jigsaw blades, moving away from your marked line, and then the tool launching away from the material. So as you're cutting, the jigsaw bit could get stuck in the material, and then your jigsaw itself will move up and down instead of the blade. So you can make it safer by using the appropriate settings on a jigsaw, which we'll go over in a bit. And you can also clamp both sides of the material and cut more slowly. This means that anywhere you get caught, you'll be able to react quicker to removing it. Use the appropriate blade for the material. Again, the same as hacksaw blades. Jigsaw blades come in a variety of different shapes and sizes. The larger the TPI number, the more teeth there are per inch on the blade. So again, the same applies. The denser the metal or material you're cutting, the more teeth per inch you want on a jigsaw blade. And then, yeah, before you remove the material or the jigsaw, you want to wait for the blade to stop moving entirely. So we'll switch over to the camera view. I'm gonna move the line like here, dude.
On
the settings?
yeah, so on the jigsaw itself,
Right,
two different settings. So first of all, you have this knob on the side here, which will adjust the angle of the blade itself. We've got a nice little handy guide on the side of this one, but you generally want to adjust that depending on what type of material you're cutting through and how thick it is.
That is not necessarily on every jigsaw.
Yeah.
Oh, right. You need to be behind the table because the microphone.
Microphone. Right. Yeah. The second point of adjustability on a jigsaw is usually a speed control, usually found up the top here, used to make the blade go faster or slower as the situation requires. As we mentioned earlier, sometimes you do want to just cut slowly to make sure that you can react sooner to if the blade gets stuck or jammed. However, in some cases, if the blade goes too slow, it will result in it catching in the material and launching the jigsaw itself upwards. Thirdly, on this jigsaw, you can adjust the angle of it. So this plate here can be adjusted to tilt to the side if you need to do an angled cut through a piece of material. Did you grab the jigsaw blade?
Yeah, there's jigsaw blade down here.
Yeah, so I'm going to put jigsaw blade in by turning this connector here.
We'll move your gloved hand up.
Yeah.
So we have this little knob here. This can be turned towards me. So it's sprung loaded, so you let go and it'll snap back into place. So you want to pull it up, insert the blade, and then let it go.
You then want to give the blade a short tug to make sure that it isn't going to come loose. You also need to make sure when you put the blade in that it's sitting inside the ridged wheel here. If it is sitting outside of the ridge like that, you're going to have a bent blade and you may actually damage the moving parts of your jigsaw.
So for a jigsaw, it's pretty loud, so you have to wear hearing protection.
I'm going to put the battery on here. And I'm just going to adjust the angle setting for the material we're using. As you can see here, I've already clamped the polycarb to the side of the workbench here. Normally, we would get a second workbench or a sawhorse on the other side to hold it in place here, but we shifted our workbench so we could record this, and we don't have that in place. Yeah, I'll just...
Oh, right. Yeah, I don't want to deafen you guys.
As you may have noticed, I was once again angling the jigsaw side to side to compensate for the blade itself twisting to make sure I cut in a straight line.
With polycarb in particular, you don't want to have your blade going too quickly. Otherwise, you're going to melt the surrounding plastics and then it'll get stuck in between the teeth of the jigsaw blade. And then if you don't notice that, it'll harden and then your jigsaw blade won't work properly until you get a file or a knife or something and get it out. Again, speaking from experience, we've accidentally done that a number of times.
Yeah. So once you finish cutting a piece of polycarbonate, you'll usually have a bit of a beard on the edge. I don't know how well the camera can see that.
Put your hand behind it.
Yeah,
Oh,
I am.
Okay.
I am. Yeah. It isn't all that visible, but there's a bunch of little bits of polycarb sticking out. Carefully, make sure you're wearing gloves because you don't want to.
Have we lost the mic?
Yeah, so you don't want to get a plastic splinter in your hand. But if anything doesn't come off, once again, you can just grab a file and run it down the side a few times. Most polycarb will also have a protective film on both sides of it, which you will want to peel off once you have finished cutting it. You generally don't want to remove the film before you cut it, because that way you can end up with scratches left in the polycarb from the tool use. And now, you can see it's nice and clear without any scratches or scuff marks in it.
As you can see, it is nice and clear. Alrighty, so the next thing we're going to do is get this piece of polycarb and then rivet it to the bit of tubing that we had cut earlier. We're also going to bolt.
Two pieces of metal. We're also going to bolt 2 pieces of metal together. So we'll do the 2 pieces of metal first.
Okay.
So when you're drilling a hole to connect 2 pieces of material together, you can either measure out the same distance on both pieces and hope that you are accurate enough with a hand drill that they both line up, which most of the time you will get it lined up, but it does happen often enough that it doesn't line up 100%, that it will cause you some issues. So the second way to do it, second way to do it is to get the 2 pieces of material and clamp one to the other. And I need a larger clamp to fit around there. If you clamp one piece of material to the other, you can then drill through both at the same time, thereby ensuring that the holes will be lined up.
Bolt through, I guess.
One bolt each side.
So with marking aluminium, when you want to drill a hole, you're going to want to use a center punch. So this, let's go over to the. So the risk of not using it or using it incorrectly means your holes will be slightly off. You can accidentally hit your hand if you're not careful. Your drill, if you don't have a properly center punched hole there, your drill bit will drift off to the side. And then if you use a bit that's too big for the job without a pilot hole, your drill can be caught in the material, and that can either mean the material will fling out or the drill will get caught and drag you with it. So to make it safer, you can mark your holes with a combination of horizontal and vertical lines. So essentially, you'll make a cross where you want your hole to be, and then in the center of that cross, you will use a center punch to mark a hole, to mark a dot where you're going to drill the hole. So this method is generally used on metal and polycarb. For wood, you don't really have a drifting problem at all. And when drilling a hole that's larger than 6 millimeters, you're going to want to use a smaller pilot hole first so that your drill bit doesn't get caught and it yanks the material away or hurts your hand.
So for the first hole here, I'm going to take the scribe and I'm going to mark a position 1/2 inch away from each edge on here. As I mentioned before, we're going to mark it on both sides of the piece of material, then take the ruler between those 2 points and draw a 90-degree line between them. Then in the center of that cross, and I'll just go over it again with a marker to make it more visible.
Show the cross. So in the center of this cross, you're going to want to position the tip of the center punch. You'll then...
That's it hidden behind your hand. Yeah, I'll put it there.
Ideally, you wouldn't hold it like this, just for demonstration. You want to position it in the center of the cross, and then you want to give it one good whack with the hammer, and that'll put a dent in the material where your drill bit will then sit and make sure that it is centered. So we'll mark the other side just quickly and then talk about, mark that side.
Yeah. So we're just going to mark and center punch the other side while Lewin talks about how to use the hand drill.
Safety. So the cordless drill. So with the cordless drill, a few risks are you can strip the screw heads, you can burn out the motor, you can hurt your wrist if your drill is set to the improper torque settings, and you can have the wandering drill bit, which we talked about when we were talking about the marking. So you need to use the appropriate bit for the job. So if you're undoing or doing up a Phillips head screw, you're going to need a Phillips head bit. You're not going to be able to use a flathead bit unless it's a combination head, which is a weird head anyway. You need to stop drilling if there's too much resistance. So like I talked about earlier, if your drill bit is too big, it can get captured on the material. And then as you're drilling, the drill will pull your arm away. And so that can hurt your wrist. Again, with the torque settings, you have, ours are really faded. Can you see if there's a drill that has it not faded?
Yeah.
So there's torque settings on here, but firstly there's, wait, I'll switch to the camera. I can't see. Okay, does that show it?
Yeah, this one has visible markings. I think
Nice.
the torque is a little bit busted though. So.
That's fine.
Yeah.
So a cordless drill has a few main components. You have the battery, which goes in the bottom. You have the forwards, backwards, and locking switch that's right above the trigger here. It's gray. You have the trigger itself, which is here. And you have on the top of it a speed setting. So you can have either 1 or 2 speed. Then you also have the clutch on the front here, this plastic ring. So on this plastic ring, you have numbers 1 through 20. So those are the different torque settings. And then you also have at the very end, you have drill, which is the highest torque of them all because you don't want your drill stopping if you're trying to drill a hole. So with the lower torque settings, it means that the clutch will engage quicker when there's even a little resistance, meaning that you can stop the screw going in all the way, or you can stop a screw part of the way depending on what your torque setting is. The higher the torque setting, the deeper you'll drive your screw and the more torque you'll have. Or you can use it when drilling into a more dense material. So because it's a clutch gearbox like in a car, your first gear will give you more torque, and so that's more used for drilling into metals or for screwing screws into a denser material, or if you want to drive them deeper. I guess we're ready to start drilling. So a drill doesn't really make too much of a noise, so we don't necessarily need ear protection unless you have a blunt drill bit that's spinning and you can hear that it's really high pitched and whiny.
Or if you're drilling through a particularly thick piece of metal like steel.
So you want to line the tip of your drill bit up with the indent that you've made. You want to make sure that your drill is straight. Some have a spirit level built into the case of the drill. You want to make sure you're on the correct setting. So you have on this little piece above the handle, you have forwards, backwards, and then in the center it's locked. So when it's locked, I can't pull the trigger. You want to keep your drill in the locked position whenever you're not actively using it. So you want to line it up on the indent you've made, switch it to drive, make sure that the torque setting is on the drill. Then you want to pull the trigger. So one thing that's also useful is to keep the drill running as you pull it out of the material. This means that it won't get stuck on anything and fling your material around. So I'll just quickly do the other side.
Yep. Then you want to use a vacuum or a brush to clear out the loose bits of chaff where possible to make sure you don't cut yourself on the metal shavings. Something you can do is just tip them directly into a dustpan. So now we have these two sets of holes which are lined up with each other because the pieces of metal were clamped on top of each other to start with. So we're now going to get some bolts and connect them.
So that moves us over into the Allen key screwdrivers and spanners. So something you can do with these is you can over torque, which means if you apply too much force when you're undoing or doing up the bolt, you could snap the head off of the bolt. We've done this numerous times to our drivetrain. With the bolts that hold our wheels onto the axles, we've accidentally torqued the heads off them, so snap the heads off. Rounding, so in the picture you can see of the screw heads, you've got a Phillips head bit that's slipped and has made it round instead of a cross. And also, if you're using a screwdriver and you're applying quite a bit of pressure because it's hard to get out, you can, if you slip, you can go right through your hand. They're actually reasonably sharp. And with the flathead ones, you can cut yourself. So to make a Allen key or screwdriver or spanner safer, you can not use them as a hammer. So again, a spanner is really heavy and you might think that, yeah, it's sturdy enough to use it as a hammer, but it's not the right tool for a job. Go and grab a hammer or a mallet.
Yeah, it's not shaped right. You're likely to have it deflect off whatever you're hitting. There's been a few viral videos floating around about people using spanners as hammers and it bouncing off and hitting them in the head. Just be careful, use the right tool for the right job.
So again, for using the right tool for the right job, an imperial size that might be close enough to a metric size is not. It's not enough. So in that example, we have a 5/32 is not the same as 4 millimeters. So if you use a imperial for a metric job, it could be slightly too small. And so it ends up rounding the head of the Allen key itself, or you can round the head of the bolt. And in both cases, either the bolt or the Allen key then become pretty useless. And with the impaling of your hand with a screwdriver, just keep your hands clear when applying pressure, like clamp the piece down or put it in a vise or something.
Okay. So on here, if you want to switch back to the camera. Yeah, so I've put 2 bolts through the holes here. What we have here are some nylon lock nuts. What this means is that you can't they have a small nylon ring in them. You probably can't see that very well. They have a small nylon ring inside them, which acts as a lock on the thread as you tighten it onto the bolt. This does mean it's often very hard to finger tighten them, but once you tighten them with a tool, they're highly unlikely to come loose due to vibrations. So we're going to start by just finger tightening them onto the end of the bolt to make sure it doesn't come off. Then we'll grab the correct size spanner and Allen key.
Yes, it is the right one. Okay.
Yep.
So you want to use either you've got your open end or your closed end, which is round. You can pick either one. I like to use the closed end because you can just hold it in place easier. And then you'll put your Allen key in the head of the bolt and just turn the Allen key whilst holding the spanner in place. In a case with aluminium tubing, you don't want to over tighten it because it will dent the tubing and that'll lead to excess stress that you don't need.
Yeah, as this is a piece of strap tubing that has been used for other applications before, you, if you can refocus camera, you might be able to see that this section right here has quite a sizable dent in it from being over tightened previously. So just be aware of that. You don't want to make your tubing crumple because it reduces its strength and can often result in other parts not lining up properly.
One way to stop that is by using a washer on either side. It distributes the force over a greater area, meaning that you're less likely to crumple or damage your tubing. And remember, with these kinds of things, it's righty-tighty, lefty-loosey. So you go to the right or clockwise to tighten, and then anti-clockwise to loosen.
Now that we have these two pieces of metal connected together, we're going to take the piece of polycarb that we cut earlier, and we're going to rivet it onto the top here. Once again, we're going to clamp it in position and drill through both pieces of material at the same time, because that makes it gives us an easier time of actually having the holes line up properly. So you can use a center punch on polycarbonate if you want to, and in some cases you will need to. Yep. So I'll measure it out now. I'm going to use a marker because scribes don't tend to work as well. But once again, I was going to mark 1/2 inch in from each edge. Yeah, and then go between the points with the ruler to create a cross, and then grab my center punch, place it in the center of the cross, tap it a couple of times to create a small indentation. Going to then do the same thing over here. Then Lewin is going to drill through those 2 points.
So once again, you want to line it up with the indent that you made with the center punch. Make sure it's on the correct setting. So drill and 1. And then you want to go slowly through the polycarb and through the metal. And then keep it going as you back it
So
up.
you may notice that your drill bit will have filled up with melted plastic. It should solidify fairly quickly, but you want to remove that before drilling into the next piece of material.
Okay, so now we're going to put a rivet in and rivet it together. So like we said earlier, there are 2 types of rivet guns. You've got your manual rivet gun, which is really kind of small, and you need to use both hands to do it. And then you've also got the, Isaac's going to grab it, the electric rivet gun. So you press the button, you hold it in until it stops, and then it does the rivet. So we're going to show you exactly what the difference in time and speed is and effort. So we're going to both start at the same time, and then we'll see, well, you'll see what happens. All right, let's go. There we go. So as you can see, this took a lot more time and a huge amount of effort to actually pop the rivet.
But now that we've done that, we have this piece of polycarbonate riveted onto our 2 pieces of metal.
Where's the white background? It looks kind of like a butcher's knife. Yeah. So now for the extremely fun part that is actually probably one of the most important parts of an FRC workshop. It is the cleaning. So first of all, you want to grab all of your tools and remove them from the workbench. For the moment, we're just putting ours underneath so that we can show you guys.
Don't worry, we'll put them all away properly once we've finished this recording. I don't know how well the camera can actually show it right now, but the workbench here is covered with tiny particles of metal and polycarb from all the cutting and drilling we've done.
I'll grab the flashlight and see if anything like bounces off. But yeah, there's a lot of.
Switch back to the camera.
a lot of stuff on it. Oh, right, yeah,
Yeah, that would
probably
help.
handy. So yeah, I don't know if anything particularly pops up, but there's a lot of stuff here from where we were doing the
Now, you often want to actually clean off the area you're working in while you're in the middle of working, because if you try to clamp something down and there's particles underneath it, it's not going to be clamped down properly and can be shifted around quite easily. So most of the time you can get away with just using a dustpan and brush to sweep off the area. But if you have something like a well-used workbench, like we have here, which has lots of holes in it from pieces of material being drilled on top of it, you will need to use a vacuum.
And also around the vise where we can't exactly get the dustpan and brush in, you'll want to use the vacuum. So headphone users beware.
You can also then use the vacuum to clean out the dustpan once you've swept everything into it, instead of tipping it into a bin, depending on what kind of garbage disposal facilities you actually have.
Your mentors will also love you if you vacuum the floor and sweep up any large things that you have on the floor.
Yeah, one thing you do need to be careful of, however, when using a vacuum is that the power cord and the hose can both be trip hazards, particularly if you're running an extension lead from one end of your workshop to the other.
Did we talk about the actual cleaning stuff? I don't think so. But yeah, so if you don't clean, you can have small particles of plastic and metal and wood all in the air. And so breathing those in are definitely not good. If you have metal and plastic shavings, they can cause cuts or splinters. And then particularly the metal will cause a short circuit in the PDP or the Rio if you get a lot in there. The material can't be clamped flush. If there's a bunch of stuff underneath it, it'll be on odd angles. And yeah, risks while cleaning, it's a trip hazard, and accidentally binning small and important parts like bits of versaplanetary gearboxes or those really tiny screws on the PDP that hold the cover in place. You don't want to accidentally suck those up or put them in the bin, because it's a pain trying to get them.
Yeah, always make sure you check your workbench area for anything important before you use a vacuum on it. This is another reason why we definitely recommend using parts trays for anything small and easily missable.
Alrighty, I think.
Yep, that's it.
Yeah.
So if there's any additional questions that have come in.
Hey guys, I had one question come in. Someone wants to know if you have any recommendations on where to get decent imperial taps.
So yeah, funny that we are a team that for some reason we have managed to avoid using taps and stuff. So we're probably not the best people to ask, but I'd say somewhere like McMastercar. Do they ship to Australia? No. Okay. So no, I don't know. Probably eBay's your best bet.
Okay.
Sorry.
Yeah, we aren't really qualified to offer advice on where to get tools that we ourselves have not actually used.
Not a worry. So what safety precautions do you take for heavy and awkward lifts? For example, lifting a robot.
So when we're lifting a robot on and off the field, we try to make sure we're using the cut-resistant gloves at all times, particularly when holding the robot in areas that have the potential to be sharp. We also try to design our robots to have obvious lifting points so that we're not holding them awkwardly. And then we make sure to lift from the knees instead of bending over when picking up robots.
Lots of teams design rope points on their robot that they then bring in hooks or something to hook in and have actual handles. We also design our robot trolley so that the robot is at a suitable height for lifting, so you don't have to go all the way down to the ground and lift all the way back up.
We then also use this elevated robot trolley as a substitute for sawhorses to put the robot on in the pit area, because it means there's less robot lifting required and we can work on the robot without having to move it around or have extra space taken up in our pit area.
We also make sure that there's not like really small kids trying to lift the 50+ kilo robot.
Yeah, we tend to try and have team members of similar heights, and particularly our stronger team members. We don't want to stick our tallest and shortest team member both trying to lift the same robot, because they will not have a good time.
Okay, good advice. Someone just wrote in that RS apparently has some Imperial taps, if anybody is interested, but they're very expensive.
Yeah.
So there you go. Well, gentlemen, that was really great. I think that so many people have learned so many things tonight. A huge thank you to you. A huge thank you to all of Project Bucephalus. I know that you guys put in a huge amount of work and you're always there to help make these recordings happen. So if there's no other questions coming in, thank you so much. Do you have any closing comments?
Thanks for having us. Thanks for organizing this whole thing. It's been fun.
Awesome. Well, good night, everyone, and we'll see you next Monday night. Bye.
Bye.